All right, so today's lesson, 11.5, is on choosing a data display. How can you display data in a way that helps you make decisions, and how can you create appropriate data displays? So some of our vocabulary for the day, we have qualitative data, which is categorical, meaning it's labels or non-numerical entries. So separated into different categories, not numbers. Quantitative data consists of numbers. So quantitative, numbers, qualitative, categories. Lastly, a misleading graph is a statistical graph that is not drawn appropriately. Sometimes it's done to give the impression that the results are better than they actually are, or worse than they actually are, but either way, it's misleading because it leads to not accurate results. It's not drawn appropriately. All right, so example 1, tell whether the data is qualitative or quantitative. Prices of used cars at a dealership. Key term here is prices. Prices are numbers, so we're going to say that that's quantitative. All right, and then jersey numbers on a basketball team. This one's tricky because it's jersey numbers, and the numbers makes you want to think quantitative, but a jersey number identifies a player the same way as like their last name would, which is categorical. So jersey numbers on a basketball team, even though they're numbers, we're going to say it's qualitative because it's categorical. All right, and lengths of a song at a concert. If you're measuring lengths, that's a number, which means it's quantitative. And zodiac signs are a category, so that is qualitative. All right, example 2 says analyze the data and then create a display that best represents the data and explain your reasoning. So first, I want us to look at the data and see what it is we're measuring. We're measuring eye color of students. So there's categories of color, brown, blue, hazel, green, gray, or amber. And then there's the number of students with that color of eye. So before I give you the answer, I want you to pause and think, what kind of display do you think would best represent the data? Some different options are line graph, line plot, stem and leaf plot, box and whisker plot, bar graph, pie chart, circle chart, histogram. That should be enough. Hopefully you decided that a bar graph or pie chart or circle graph would best display this data. I'm going to choose to display it in a pie chart. And there you go. There's my pie chart representing the data from the table. And it says explain your reasoning. The reason that I chose a pie chart or why a bar graph would display the data correctly is because those both show categories very nicely. These are categories out of a total number of students interviewed. The categories don't really affect each other, but it's a category, so each category could have a ratio or a percent, which is why I think a pie chart would be the best way to display the data. All right, so as we decide what kind of graph would best display this data, there's a couple of things to consider. First off, the data is numerical. Second off, there are probably many numbers that repeat. So something that shows the frequency would be a good idea. And then there's also 2 categories. So we want a graph that can show 2 separate categories. Now remember, bar graphs and histograms can also be double. A bar graph isn't best because bar graphs are better for categories. A histogram could be a good option. You could do a double histogram and separate the speeds into intervals. I'm actually going to choose a double box and whisker plot because there are so many numbers here. Instead of counting every single one, a box and whisker plot allows us to only use the 5 numbers. So the least, lower quartile, median, third quartile, and highest data value for each set. And then we can compare the distribution of each data set. All right, so example 3 says, describe how each graph is misleading. Then explain how someone might misinterpret the graph. Well, let's look at example A. This is a bar graph displaying the tuition, room, and board at all colleges and universities. So for the academic year of 2007 to 2008, it looked like it was about 16,500. And then that looks like a huge jump to the academic year of 2010-2011, where it really only grew by about 1,500 to 18,000. So how this graph is misleading is because the y-axis begins at 15,500, making the increase look much more dramatic than it actually is. It looks like it doubled in 4 years, but it barely increased by 1,500. All right, and part B displays the mean hourly wage for employees at a fast food restaurant. This shows the year from 2008 to 2013. And again, if you look at the y-axis, it starts at 8.9. At least they show that there's a break here, but it still makes the increase look more dramatic. This graph is also misleading because the increments on the y-axis are not equal. It looks like the biggest increase is from 2011 to 2012, when it jumped from $9 to $9.04, $9.04, but it's actually from 2009 to 2010, which is when it increased from $8.93 to $8.98. The increments on the y-axis, some count by 2, some count by 1. They're not even. That's misleading. All right, so some summary questions for you. What is the difference between qualitative and quantitative data? Well, quality means categorical, it's categories, and quantitative, so quantity, means it's numbers. All right, give an example for when you would use a data display with qualitative data. Well, qualitative or categorical data is better shown with a pie chart or a bar graph. Give an example for when you would use a data display with quantitative data. This is number data, numerical data, so box and whisker plots, stem and leaf plots, histograms, things that represent numbers. All right, a misleading graph could have maybe the axis is mislabeled, or maybe it has not even intervals or starts at a weird place. A misleading graph is not drawn appropriately. It makes the data look worse or better than it actually is, and it's misleading.